the law of large numbers applies to relative frequency approach to probability. And what it's saying is the more number of times you conduct an experiment, the closer you will be to approximating the true probability of an event occurring. So let's say the probability, if I roll a die, of rolling a 1 is 1/6, right? This is the classical or theoretical probability. But I'm going to conduct an experiment. And I roll a dice, I roll a dice 12 times. And from this, I see the probability of rolling a 1 was actually 3 out of 12, which is a fourth, which is more than what we know the actual probability to be. So what if I do this again? What if I roll a dice 24 times? Okay, 1/6 is 0.17, by the way, 1/6 bar. What if I roll a dice 24 times? And then I'd see the probability of getting a 1. If I conduct an experiment rolling a die, I actually get 3 out of 24, which is 1/8. Okay, we're getting a little bit closer. But what if I roll a dice 240 times or 12,000 times, right? We could assume the probability of rolling a 1 gets incredibly close to our classical probability. So, for example, a roulette wheel has 38 numbers. 18 of them are black, 18 of them are red, and there's 2 0 numbers in green. And we're going to assume that all outcomes have the same probability. So what's the probability of getting a red on any spin? So the probability of red, for if we're going to do classical, would be 18 out of 38, which is 9/19. What if I was a patron, though, and I conducted my experiment 100,000 times? How many times would I expect to get a red number? So this 9 out of 19 is a decimal, is 0.47. So I could take 0.47 times 100,000, and I would get 47,000. So if I was able to roll the roulette wheel 100,000 times, I could expect a red number 47,000 times, which is a lot. A couple more definitions is that in a possible event is an event that cannot occur, and a certain event is an event that's sure to occur. So if A is the event that Thanksgiving will be on December 25th in the year 2000, then A is impossible. Well, why is that? Thanksgiving is always the fourth weekend in November, and December 24th is Christmas. A certain event is one that is sure to occur. So if B is the event that Thanksgiving will be on the fourth Thursday in November in the year 2000, that is certain. Well, Thanksgiving's on the fourth Thursday every year, so that's certain. So the probability of this event is 1, and the probability of an impossible event is 0. A complement of event is the set of all events not in A. So let's say A is rolling a 6, if we were to roll a die, then A bar would be rolling a 1, 2, 3, 4, or 5. Okay, so that would be the complement of an event. So let's say the experiment is to toss 3 coins and count the number of heads face up. If A is the event that exactly 2 heads are face up, then A bar is the event that either 0, 1, or 3 heads face up. If the experiment, so here's another experiment. If the experiment is to clock a car's speed as it passes through the intersection of Big Bend and Rye Down. These are two roads right by our campus here in St. Louis, Missouri. If A was the event that the car is speeding, then A bar is the event that the car is not speeding, which is exactly how one should drive. It's important to note that the probability of an event occurring and the probability of an event not occurring is 1. Okay? So like the probability of getting heads is 1/2. Probability of not getting heads, which is tails, is also 1/2, and that adds up to 1. So it says that the sum, which means add, of the probabilities of an event and its complement is 1. We could also rewrite this by subtracting the probability of A from both sides, and we'd find that the probability of A bar, I used to say hat, now I have to say bar. A bar is 1 minus the probability of A. Odds are the ratio of an event occurring either way based on the probability based on the expected probability either way. Okay, what does that mean? So the odds against an event occurring are the probability of A not occurring over the probability of A occurring. So those are the odds against. Odds in favor are the probability of A occurring over the probability of A not occurring. So let's experiment in flipping 3 coins. And probability of A is the event exhibiting exactly 2 heads. So probability of that occurring is 3 out of 8. And the complement of that is 5/8. So the odds against, that's when we put the probability of it not occurring in the numerator and the probability of it occurring in the denominator, simplifies to 5/3. So that's typically said 5-3. And the odds in favor of A are 3/8 over 5/8, which gives us simplified down to 3/5. And this is read 3-5. And just in case you're wondering where I got my probabilities from. All right. So section 4.3 is about the addition rule. So first thing we need to talk about is either or probabilities. So for non-overlapping events, these are events that can't occur at the same time. For example, if I'm flipping a coin, I can't flip a heads and a tails at the same time. Okay? So when I have non-overlapping events, this is what their Venn diagram would look like. There's no overlap. So non-overlapping events, like I said, cannot occur at the same time. So if A and B are non-overlapping events, then the probability of A or B would just be adding together the probability of A and the probability of B. And this can be extended to any number of non-overlapping events. So why don't we do a couple examples? So suppose you roll a single die. What's the probability of getting an even number? So I could roll a 2, a 4, or a 6. So that's going to be the probability of rolling a 1 plus the probability of rolling a 4. Sorry, the probability of rolling a 2 plus the probability of rolling... Let me rewrite this more neatly. Sorry, guys. Okay, so this is going to be the probability of rolling a 2 plus the probability of rolling a 4 plus the probability of rolling a 6. So that's 1 out of 6, because it's a 6-sided die, plus 1 out of 6 plus 1 out of 6, which gives me 3/6, which is a half, or 0.5, or 50%, right? So the probability of getting an even number if you roll a dice is a half. What's the probability of rolling a prime number? Okay, so my prime numbers are 2, 3, and 5. Oh, that's not very exciting. It's going to be the same as above. That's okay. So the probability of getting a prime is the probability of 2, the only even prime number, very exciting, plus the probability of 3, plus the probability of 5. So again, I have 1/6 plus 1/6 plus 1/6, and that equals a half. So those are some examples of either or probabilities. Two events are mutually exclusive if they cannot occur at the same time. So we could also say that non-overlapping events are mutually exclusive. Since A and A complement, red A bar, can't occur at the same time, we always know that A and A bar are mutually exclusive. And so the probability of A or A bar is always going to add up to 1. Now, if events are overlapping, that means they can occur at the same time. And if they're overlapping, the probability that A or B occurs is the probability of A occurring plus the probability of B occurring minus the probability that A and B occurs. Now, this last term, it corrects for the double counting and it's for the probability of A and B, which is the probability that both events occur together. So, for example, to improve tourism between the United States and France, there are 2 governments to form a committee consisting of 20 people. 2 American men, 4 French men, 6 American women, and 8 French women. So I want to know the probability that you are a woman or you are French. So I have to take the probability that you are a woman plus the probability you are French minus the probability that you are a woman and French. So let's look at this table right here. So here I have men. I've got 6 men and 14 women. 8 of the people are American and 12 are French. And this was out of a committee of 20 people. If you see, if I add 8 and 12 gives me 20 and 6 and 14 gives me 20. So I always recommend finding sums of your tables. It's a great way to start. So the probability that you're a woman or French is the probability that you're a woman, which is 8. So that's our event, our observed number of that event occurring out of our possible sample size, which is 20. The probability that you're French is, the probability that you're a woman is 14. I'm too close to this tablet, I swear. The probability that you are French is 12 out of 20. Now, as you can see, here's a probability that you're a woman, and here's a probability that you're French. I've double counted this 8 right here, right? This is the probability that you are a woman and you're French. If I didn't correct for this by subtracting it, you can see right now I'd have 14 plus 12, which is 26. 26 divided by 20 is a number greater than 1, and we can't have a probability greater than 1. So that's a good thing to keep in mind to check yourself. Make sure you never get a probability greater than 1. So I'm going to subtract 8 over 20, and that gives me 14 plus 12 minus 8. 12 minus 8 is 4. That gives me 18 out of 20, which is 9 out of 10, or 90%, or 0.90. So if I picked a person at random, there's a 90% probability she's a woman or she's French. So this table relates to the weights and heights of groups participating in an observational study. So in order to find some probabilities, the first thing I want to do is find the total of each column. Okay, so why don't we go ahead and do that? We'll start with our columns. Columns are vertical, horizontals are rows. So height for tall, I have a total of 50. For medium, I have a total of 104. For short, I have a total of 51, and I need to add this total up, okay? So it looks like I have 205. For obese, we've got 18 plus 28 plus 14, so I've got 60. We've got 20 plus 51 plus 28, 99. And then we have 12 plus 9 plus 25, so 46. So, what's the probability that someone from a group is tall? We'll call it event T. So, the probability that someone is tall, we go to our tall column, and I've got 50 tall people out of 205. So, that would give me 0.24 or 24%. I want to know next, what's the probability the randomly person is obese and tall? So obese and tall is where they would overlap. So here we have obese and here we have tall. I have 18 out of 205 who are obese and tall. So the probability of obese and tall is 18 out of 205, which gives me 0.088 or 8.8%. Continuing our example, I next want to find the probability that a randomly chosen individual from this group is tall and underweight. So what's the probability that someone is tall and underweight? So the probability that someone is tall and underweight is going to be where tall and underweight overlap, which is 12 out of 205. But we haven't even got to practice or yet, okay? So what's the probability that someone is tall or obese? What is that? So that's going to be the probability that someone's tall minus the plus the probability that someone's obese minus that overlap, right? Where someone is tall and obese. So I'm going to have the probability someone's tall, which is 50 out of 205, plus the probability that someone is obese, which is 60 out of 205, minus 18 out of 205. That's going to give me 0.45%. So, sorry, 45% or 0.45. You could also have this as a fraction, which is 92 over 205. So what I want to know is, are the events obese and tall independent? Remember, events that are independent have no overlap in our Venn diagram. So these events are not independent.